Hi there, Miss Lambs here. In this video, we would like to talk about the analysis part in the biology IA. For the analysis, because there's such a large topic, this will be separate into two videos. The first video will be talk about tables, and then second video will be talk about graph and statistics analysis. So let's get started. For the analysis, it takes up about 6 out of 24 marks. So actually, this is quite an important sections. What should you be included in this part will be, for example, the qualitative observations. Okay, you need to write a description of what you observe in the result. This is already covered in the previous video, so we'll skip that. In this video, we're mainly focusing on item number 2, 3, and 4. So for example, how you present your raw data. And then after you present your raw data, then you need to present your formulas and sample calculation, assuming your experiment will include an process data. So bear in mind that not all experiment will have a process data. Okay, a good example is such as, for example, let's say you're looking at the antimicrobial property of honey, then what you're observing, the inhibition zone diameter is already a sufficient dV. Okay, so the raw data. So raw data itself is good. But for example, another experiment such as you calculating the photosynthesis rate, okay, under different conditions, okay, then your raw data may be the height at the start and the height at the end, okay, so those are the raw data. And then what you need to do is later on you need to calculate the percentage growth, okay, of plants. So then you need to present the data formula and also need to present one sample calculations, okay. So here things like that, and then finally, after present the formula and sample calculation, then you will present a table of the process data. Now then you will include 2 more columns on the average and SD. So make sure that you don't put the average and SD for the raw data. You only place the average and SD for the process data. Okay, assuming your experiment do have a process data. And then for item number 5 and 6, okay, graph for process data and statistic test will be in the next video. So let's move on to the next part. This slide is just to remind students that don't flood your lab report with excess data. So what do we mean? So let me give you an example. For example, some students were doing about plant growth and they were calculating the percentage change of height, okay, in terms of the plant growth. So what they do is they measure the initial height of the plant day 1, okay, and then they measure the height of the plant every day. So on day 2, day 3, day 4, and day 5. And turns out that they select, day 4 is the best day to set as the end date because it has the most differences. So in this case, the important data would be what happens in day 1 and day 4. And the not useful excess data will be what happens in day 2, day 3, or day 5. So you should be able to screen out the data from day 2 and day 3 and day 5. Okay, so and including the day 1 and day 4 data as the raw data in your lab report. So I have some feedback from students saying that, oh, Ms. Lam, but my experiment is really labor intensive and I want to show the examiner I've done a lot of work in this lab report. So what can I do if I really want to show my excess raw data? So by what I mean is that what happens in day 2 and day 3 and day 5. Then what you can do is you can put those excess raw data in the appendix. But bear in mind that there's a risk because you only have about 12-page limits. So you don't want to exceed that 12-page limit. So you need to think about it. If you're not sure, always welcome you to ask your biology teacher for advice. And then finally, just a reminder that because we need to screen out those not useful data, so generally speaking, we will need 1 graph per lab report. Again, if you're not sure, you can ask your biology teacher about this. Alright, so this slide shows some of the common errors in the result table. So for example, the IVA-DV header is unclear or missing. So you should make sure that it's very clear the 3 items that you need to know. The items, the unit, and the uncertainty. So second thing is the unit is in the data, so that is wrong. You should make sure that all the units is in the header only. We've been talking about this since IGCSE already. And the next one is data not in the same decimal place. Now, we've also mentioned this since IGCSE that you should have all your data in the same decimal place. So if you have one decimal place, then it should be one decimal place throughout. Uncertainty, okay, is related to the equipment, and so you should include that in your header as well. And one more thing is that according to the TSM, teacher support material, they suggest that the IV, your independent variables, should be in the first column. Okay, so what happens is that if students have set up the table in horizontal manner, then the IV will not be in the first column. So this is not recognized as correct. So a correct way of doing it is to put the IV in the first column. In the next few slides, you will see some of the examples. After you present your raw data, then the next part will be, assuming your experiment do have a process data, then will be the formula and sample calculation. Now this slide is about how you present them. If possible, try to type it in a mathematical way. Okay, so that you can, as you can see, this is how you type it in mathematical way, rather than just a single line. Okay, because if you type in single line, it's very easy for examiner to skip it. Okay, or when they scan it through, they miss that out. Okay, so make sure you type it properly. Okay, so we prefer the second method. Okay, and then again, we want to stress the importance of a good header. Okay, so make sure there are 3 essential things that you need to mention. One is the labels. Okay, and then second thing is the unit, and third thing is the uncertainty. So you should have these 3 things in your header. Okay, so let's see an example of how a good table should look like. Okay, so the table here, you can see that this is the IV. Okay, this is discontinuous data. So water, and then find one of the herbs. Okay, and then this student did 15 times, and then they measure the inhibition zone diameter. Okay, and so on. Okay, so you can see that. Okay, so they have the labels. Okay, and then they have the units. Okay, units, mm. Okay, actually in hindsight, the average and the standard deviation should also have the units and uncertainty. Okay, just a reminder. And then one more thing is that because the table is set up vertically, okay, vertically, so it is possible that it might exceed 1 page. So what you should do is, on the second page, you need to insert the header again. Now, why do you need to insert the header? Is because if you think about it, if you're the reader, you don't want to flip the page over and over again, okay, back and forth again, in order to know that, oh, what this column is about. So make sure, if let's say if your table is across 2 pages, then on the second page you should include the header again. So again, we mentioned that the importance of header. Make sure that you have the header on the table. Okay, you can also pause this video and then read this one. This is actually coming from the TSM as to what you need to look out for the tables, such as already mentioned about the units. Okay, we also mentioned that independent variable should be in the first column. Okay, same decimal place. Okay, and this one special part is that the mean value should not have more decimal place than the raw data. Okay, so a decimal place should be consistent with the columns, and then the average, okay, and SD should not have a different decimal place. So for example, your data here is 2 decimal place, then your average should be 2 decimal place, SD should be 2 decimal place. So that's the idea. Okay, so what is a not so good examples? Okay, you can see here. First of all, this is a process data, and they were doing yogurt before fermentations, and then we don't know what that is. Okay, so but we know that it's a time. And then yogurt after fermentations, again we don't know what that is. So actually what the student is looking at is the flow rate of yogurt. So if let's say the yogurt has been fermented, it becomes from more fluid to become slightly semi-solid. Okay, then they're looking at the flow rate. So if the yogurt has been matured, then in theory the flow rate should be much slower. Okay, so that was that about. But then it's very unclear. But unfortunately, this is very unclear. Okay, so actually they should be using a float rate and things like that. Because think about it, this is actually the process data already. And second error that they made is the standard deviation should have the same decimal place as the data as well. Okay, so and also if it's a process data, you should not have the yogurt before and yogurt after. You should have the differences. Okay, so and so on. So process data, basically process data. So this is not a very good example. You need to standardize it. All right, and the next one, process data. So Previously in raw data, we mentioned that raw data, you should not have the average and SD. You should leave the average and SD until the process data table. Okay, so we want to avoid the loss of data. Okay, if you think about it, if you have calculated the average of the height on day 1 and the average on height on day 2, then you would not have calculated the individual percentage change, and you wouldn't be able to calculate the average and SD. So basically, key idea is that you only do the average and SD at the very end. Okay. Yeah, again, so this is just a reminder, you should do a formula and sample calculation before you show the process data table. All right. And the next part, this is actually extracted from the examiner report. You can pause the video and read this in detail. But if you don't have the time to read it, just very quick one is that the number of repeats. So for example, if you have, in theory, IB recommends students to do 5 repeats per increment. 5 repeats per increment. So then you can use the standard deviation to do the error bar. Okay, but let's say if you are running out of time and resources, you can only do 3 repeats per increment. Yes, you can still do 3 repeats, but in that case, then you can only use the range. Okay, you can only calculate the range and use the range as the error bar. Okay, so yeah. And then another common feedback, feedback from the examiner is that a lot of students mentioned the word rate in the RQ research question, but in the end of the report, they did not calculate it. Okay, so that's incorrect. So you are not really doing what you have set out to do. Okay, so again, if you have mentioned the word rate in your RQ, then in your process data, you should have calculated the rate. All right, next one. So that's it for the table part in the analysis part, okay, for the biology IA. So I hope this video helps you and guides you through along the way. So that's it, and at all, and bye for now.